All right, thank you for the introduction. Good to be here. I know it's been an absolutely amazing conference, probably the best blockchain conference I've ever been to, I think, and I don't think I'm alone in that assessment. So today I've brought a presentation that's an amalgamation between some of my own slides and then also some slides that were produced by my inimitable colleague Dominic Williams, who unfortunately can't be here today, but I'm here in his place, and I've got some pretty cool content for you guys. The first thing I want to talk about is give a quick overview of random beacon-based consensus in the way that we have instituted it at Dfinity, and I've just kind of generalized this as random beacon-based consensus. And then I want to talk a bit about product-driven research and development strategy. And yeah, so may as well just get straight into it. So random beacon-based consensus. In Dfinity, we've taken the approach of trying to look at all of the tools available to us from the field of cryptography and use those to build the most performant consensus mechanism possible. And we've based this in the creation of, in the generation of unpredictable, unmanipulable, deterministic randomness. And this is a very, very high overview. So you know, we can tackle the nuts and bolts in the Q&A. But essentially, we use something called threshold cryptography. How many people are familiar with threshold cryptography? Okay, I see 5 or 6 hands. That's good. So essentially, it's very similar to traditional public key cryptography, only the private key is split into multiple pieces, and once those pieces have been used to sign a piece of data, a majority of those signature shares can be aggregated to create a complete verifiable signature. And we use this to institute a committee-based system that doesn't require leaders. So because we only require a majority of the signatories to generate a signature share and then aggregate those signatures to create a verifiable signature, we can afford to have some of those participants offline or Byzantine without actually jeopardizing the functioning of our random beacon. So how do we take threshold cryptography and use it to create a random beacon? Well, first of all, bear in mind we have a node base. It's a known, it's a fully registered node base. We use a proof of stake system. And we arbitrarily select our first committee from that node base. And then that committee runs a distributed key generation algorithm that gives it the pieces of the private key and the public key that can be used to verify a signature generated by this committee. And this committee then uses its pieces of the private key to sign the randomness that was used to select it. Then that signature is used as input to select the next committee. And of course, a digital signature being effectively random, or certainly unpredictably random, this gives us the ability to create a random beacon in perpetuity by continually selecting a committee from our node base, and then that committee using its threshold key pair to sign the randomness that selected it. And this can happen extremely quickly. And we use this randomness to drive a number of systems in the protocol. So the way we use this to generate consensus is we use this randomness to deterministically shuffle all of the nodes in the network. And the higher ranked nodes, after being shuffled, are more likely to have their block accepted and added to the accepted, signed, and added to the blockchain. We can talk about the specifics of how this works, but probably not in the short amount of time allotted to me here today. The cool thing about this is that we can use the same committee that generated the randomness to sign blocks. And this gives us this amazing, extremely rapid, leaderless consensus system. And this is at the heart of a lot of the work that we've been doing. This has been the foundation of our entire project. And again, the whole idea behind this is using these advanced cryptographic tools to build new products. One more thing, we blind the network identities of all of the participants in the network so that no one can be persecuted for participating in the Dfinity network, and also to protect against denial of service attacks. So turning now, that's the overview of Dfinity, and I'm happy to follow up a little bit more in depth in the Q&A. But now just to look quickly at how we approach research and development. And we do this from a product-oriented perspective. And in order to do this, we need a product. And I would define this product as broadly, or the market for this product, as cloud services without platform risk. And platform risk is the kind of risk you have when your business relies on another business in order to function correctly. So, for example, if you're relying on Amazon to provide a service and Amazon goes down, then your service has been disrupted. And this has happened numerous times. Amazon's pretty good. Amazon Web Services is pretty good, but we do know that it happens. And of course, if you look at systems like, if you look at businesses like Facebook or LinkedIn, there is a long history of treating certain businesses that use their service or use their platform preferentially to others. And this has got to the point where venture capitalists assess potential investments for platform risk prior to investing. And this kind of gives us an actual economic imperative to come up with a solution for building platforms or building products that can serve other businesses without having a central point of control that can kind of be used to disrupt that particular business. So with that being our market, what's our product? Well, our product is the internet computer. And I love this phenomenally general term because it really just describes a user experience. And that user experience is that of just using a computer that lives in the internet. And there was a really great quote by someone whose name escapes me at the moment. If I had notes, I'm sure I'd remember, about how the whole idea of Amazon Web Services was to make the internet itself the operating system for a compute environment. And they came close, but we do know that there's a ton of overhead involved in actually using Amazon Web Services. There are a ton of small microservices that are involved. And if we can kind of abstract as much of that away and create something that is simpler to use, as well as being decentralized and not suffering from platform risk, then we've created something that we believe the market will accept. So the way we look at this is, first of all, what services, what tools are out there that we can use to build this product today? And this is obviously the first place that you look as well-developed strategies and a well-used toolkit. Then we look at what is technologically feasible but has not yet been implemented, and this is where we turn to the depths of cryptography and cutting-edge research. I mean, the sheer number of innovations and the sheer number of things that have become possible now that we have zero-knowledge proofs is just phenomenal. It's totally changed the way that we even think about innovating in the identity space. And all of these ideas have only been available to us since the advent of ZK, snarks, starks, and bulletproofs, and which I know that everyone here will be familiar with. So we then look at what is these unique possible technologies, these unique possible tools, and these existing tools, and how they can be combined to deliver a product that we consider to provide what we call transformative value. That is, meaningfully transform a market for a specific service. And this then turns into a prospective product design. But in doing so, through this process, you find that in combining all of these different tools, there can be some like vague incompatibilities that take us all the way back to the drawing board. And this is a process that within Dfinity we've been iterating on for almost 3 years now as we move toward this vision of an internet computer that can legitimately disrupt the cloud services industry. And actually, further to that point, I've been podcasting in the blockchain space for a few years. I mean, 4 or 5 years now, I think. And I've always been trying to think, what are we really building? What is the end game? And I think this notion of a kind of a compute environment that lives in the internet is kind of starting to get there. And I feel like this is something that can apply not just to an organization that is innovating and building a defined product, but I think it also applies to the communities that we've managed to build over time. And so our platform that, once we've built this platform, right, it has to have customers itself. And who are those customers? Well, they're people who are delivering transformative value to others. And this vision of an internet computer, I'm sure everyone will be able to identify with. It must be fast and scalable. It has to be secure. It has to be aligned with industry standards, existing industry standards. It needs to have extremely easy to use and robust developer tools. And as we've seen with all of these challenges relating to KYC and identity verification, if this is going to be a value-bearing network that interfaces with businesses in the legacy world and meat space, then it is going to have to be able to meet local compliance requirements, and that is going to mean that we need a strong identity system built in as well. So all of these are problems that need to be delivered upon before we can get to that next layer of delivering valuable, usable services to kind of the broader business market. And once we have that, then we've got something that people can use to build businesses themselves on. And if this is truly decentralized and can provide a competitive user experience, then we've met this goal of providing a decentralized cloud, free of platform risk. So that's the high level. That's the research approach. But once this product is ultimately assembled, once this is fielded, and again, this applies to all products in the space, there are some minimum requirements, not just of the ecosystem, the product itself and the ecosystem it lives in, but also organizational requirements and kind of the supporting services that need to exist to maintain and the product and also to serve the users of that product in the future. So the full set of, there's more than just as what is on the slide, but the full set of requirements required to just build this kind of product includes things like new virtual machines, parallel execution of code that is running on these machines. Obviously, a sharded architecture is essential as well if we're going to have scale. Identity, again, we need new languages and compilers for these languages. We need new networking protocols and, again, mature developer tools. And all of these components need to be built for these specific computing environments. This is actually what's quite marvelous about Substrate, is the incredible work that's being done to build out all of the necessary components. Because it's not enough to just build, say, a really powerful, fast consensus mechanism. There's a ton of stuff that goes into a usable computing environment. And secondly is the actual organizational support for something like this. Certainly we found internally, we need a research team to support our engineering team. And then operations, marketing, our community management, legal has been a huge overhead that we've found in assembling a system that actually interfaces with the meat space world, with the legacy world. We need to take into consideration what systems already exist before we go building building services for them. Recruitment has been phenomenal, and then developer outreach finance. This is focused on a specific closed organization. But I think what is really spectacular is that in walking around the conference for these last couple of days, I've found that certainly the Web3 ecosystem has managed to bootstrap most of what I've described on these two slides. I'll let go back. No, well, it doesn't need to. There we go. Most of what I've described on these two slides just through the community itself. And I think that's what's made the Ethereum and now the Web3 communities so vibrant and so functional and so awesomely innovative. And while admittedly at Dfinity we're doing this internally, I think it's really awesome to see this approach mirrored in the organic self-organization of the community that really has turned up here today. So, for these last couple of days. So that's my full presentation. I'm happy to take Q&A or go over the consensus part of that again. But yeah, sure. Do we have a mic? Do you have a microphone? No? No.
Yeah, hi. Thanks for the cool talk. When you were talking about the legal team, you pretty quickly switched from like legal concerns to integrating legacy systems. Like, isn't integrating legacy systems just a technical issue? I think in the legal space there are really very different challenges we have to tackle with like those new technologies. Like the law just isn't having a place for ways of thinking and ways to approach problems to like make them fit on the law. And nowadays just people think that it's not compliant or that it wouldn't be allowed, but in a sense that the legal problem at the moment I see is that the law just didn't think of anything that we have today.
Right, so the response to that is that we should be designing our systems to build systems that are compatible with the law. We shouldn't be comfortable just saying, I'm sorry, you guys didn't plan for this, everything's changed. We should be able to emulate systems that are compliant with those. And this is not a anti-anarchist attitude. This is just a pro backward compatibility in the social sphere.
I love this microphone. All right. So long version, short version, it's kind of a really low-hanging fruit question. What is next for everybody to look forward to regarding goalposts on your roadmap that's sort of digestible? Short version, when moon?
Oh, right. When moon, I have no idea. You can ask Elon Musk. But yeah, right, Mars. Yeah, I mean, I can't really speak to that because we've just brought on a VP of engineering who's just basically scrapped our old roadmap and said, do this. And of course, a roadmap depends on launch configuration, either like how soon you want to launch, and then what your launch configuration is, and those are two, and how many people you have. And so those are three opposing concerns. And so we're in the process of totally redrawing up our roadmap right now.
I have a simple question. Is it working? Okay.
Oh, there you go.
I have a simple question, but can you show maybe the last slide again, or?
Sure. This one?
Yeah, you said this all has to be developed, so I'm maybe interested in languages and compilers for Dfinity and decentralized network protocols. So are you using something existing like MQTT for local networks or libp2p, which is now also modular, or what are you developing in this regard?
So we did look at libp2p, and we did prototype a bunch of stuff using libp2p. But in the end, we wound up developing our own networking. Again, part of that is to do with, and I mean, this is like technical, and I'm a comms guy, but part of it was feeds into this blinded network identities. The other thing is we wanted to have a system that constantly reorganized the network. And so that was another consideration to do with that. We want to restrict what the node set that any particular node is connected to. That was one critical part of the
distinguish between TCP/IP public network, which is outside of your net router, and inside, when you can have more and more computers like microprocessors, Raspberry Pis, and they are not visible from the outside network. So
Yeah, I mean, I don't know. Yeah. Languages. So yeah, so we are using the actor model, and we've built this on top of the WebAssembly virtual machine. So we use WebAssembly bytecode, and that's our compile target. But we also use the actor model, programming model, so that pardon? Actor. No, actor from who was? Oh yeah, right. I think the one that they use for the European Telecommunications Network. I don't know. But yeah, so okay, yeah. So it's, I mean, anyways, yeah. So we use the actor programming model, and we needed to build in a whole bunch of core functionality to use that into a programming language. And so we're in the process of developing a new language called ActorScript that will launch with that. But you can actually compile. It's still just the WebAssembly virtual machine. So yeah. So you can compile anything to it. Yeah. Yeah. Yeah, right.
Okay. Thinking about the Web3 ecosystem, it's obviously interesting to understand how Dfinity is going to integrate with Substrate and Polkadot. Can you tell us something about that?
Well, right now we haven't thought about it. Right now we're literally just trying to build a product that will serve the market that we've selected. But I mean that's something that should be trivial at the end of the day, because there's no reason why we can't. Yeah. Yeah. Meta, right? Yeah. So I mean, yeah. So there's not. Yeah. It's a that's not something that we're tackling directly, but anyone can do that for us. Any other questions? No? Okay. Well, if that's it, thanks for having me, guys. Real pleasure, and look forward to chatting with all of you later on in the day and on into tomorrow.